Welcome. It's always good to get a bit of audience interaction going. How many of you are telecoms engineers in the audience? I kind of am. Okay, maybe it's just me. Sometimes it's quite nice to sort of revert back to talking about things to do with frequency bands and propagation characteristics and so on. And in this session, we may touch on one or two of those kinds of topics. We're talking about 2.4 gigahertz LoRaWAN. I'm Matt Hatton. I'm one of the founding partners at Transforma Insights. We're an industry analyst firm focused mostly on all things IoT. I will let my panel introduce themselves, starting with Dave Belcher. Dave.
Okay, hi guys, thanks for coming today. It's really great to see so many faces here. I'm Dave Belcher, I'm from Convert Technologies. We are a technology company. We develop technology IP effectively. And really our specialism is in location, specifically indoor location. So that's really why our focus has been on 2.4 gigahertz.
Excellent. Next along is Thomas Brunner. Thomas.
Yeah, hi everyone, I'm Thomas Brunner. I work for Miromico, an engineering company based in Zurich in Switzerland. We develop custom projects for our customers, mainly in the IoT and of course mainly in the LoRaWAN area. We worked a lot in the past with 2.4 gigahertz and I'm happy to attend this panel today.
Excellent. And Deniss Truhanovs. Deniss.
Hi everyone, my name is Deniss Truhanovs. I'm a head of product development at Mikrotik, working for 18 years already for Mikrotik. So Mikrotik is a networking equipment provider. So the IoT is a small part of our business, but still doing a lot of products for LoRa. So that's in short, thanks.
Okay, good stuff. The first thing I've been asked to cover is maybe an overview of, not I've been asked to cover, these gentlemen have been asked to cover, overview of recent technical advancements in 2.4 gig LoRaWAN, how they compare to sub-gigahertz. So Dave, if you can start off with that one.
So I think hopefully you've all heard of 2.4 gigahertz LoRaWAN. I mean, I feel it's a technology that's been kind of brewing in the background and everyone is sort of waiting for it to explode. So I think part of the issue here is everyone's looking for the killer app. Hopefully by the end of this podcast, everyone's going to be very clear what that killer app is. And I think really now we are just getting to the point, you know, these guys, the providers are really driving forward in providing end devices, gateways, TTN obviously providing 2.4 stacks as well. So the whole of the ecosystem is really poised to start making that jump and making that leap. And hopefully we can convince you today why you need to make that leap and where it's appropriate and perhaps where it's less appropriate to do that, make that step.
Now, Thomas and Deniss, anything else technical before we get on to the more interesting commercial stuff? Anything additional to add on to that? I think it was at this show maybe a year ago that we were first talking about it. Or was it only 12 months ago that we really had?
This is actually my first time here, but you know, it is certainly in that kind of time frame that it's very much an evolving platform, I think.
Okay. Anything else on the technology evolution roadmap that we've seen just recently before we talk about commercials?
I mean, there are a lot of technical benefits of LoRaWAN 2.4 gigahertz. I'm sure we will talk about this in length later. I mean, just to cover the main benefits, I mean, of course, the regulatory question is one of the most important, I think. So LoRaWAN 2.4 gigahertz can be used all over the world and not just in certain areas of the world. For us, that is one big point.
I will certainly come back to that one, but I'm thinking of maybe the comparison between the sub-gigahertz and the 2.4 and how those two stack up in terms of capabilities.
I mean, more technical area, I would say the higher data rate of 2.4 gigahertz is one of the most important aspects. I mean, it allows for a much higher data transmission, which can be crucial to measure or log or handle data more in time than with, for example, the sub-gigahertz LoRaWAN. Okay.
Deniss, any other differences between sub-gigahertz and 2.4 gigahertz that we should note?
So the regulation is definitely one of the key points. Another is more frequent uplinks. You don't have a 1% duty cycle restriction. So this is, in my opinion, is one of the main drivers. So something you cannot get with a sub-gig. So
And that's down to the band that's being used, specifically the restrictions on the band being used, because at that sub-gigahertz 433 or 868 or others around that kind of area. Sorry, I might be being very geographically specific, but that sort of 450-ish and the 900-ish tend to have quite strict restrictions on duty cycle, right? Whereas 2.4, it doesn't have any, or it's just much reduced?
None.
No restrictions whatsoever.
Yeah.
So you can be blasting out messages to your heart's content.
Correct.
Which might, of course, become a problem in the future.
Of course. Yeah. Nothing comes for free, right?
Yeah. Okay. Well, actually, let's pick up on that. What do you mean by maybe not in the future? Would you expect that to change and there to be a change in the licensing regime around, license-exempt spectrum, but do the rules change sometime soon?
I mean, it's hard to say, but if something is unregulated or there are no rules, people tend to overuse it, and then someday there might be the need to add some regulations. So we will see about that, yes.
I think at the end of the day, there's only one spectrum, right? You can only one person can shout at a time. So if everyone's trying to do that, then you're just going to shout over each other and nothing's going to happen.
But this is a band that's been used by Wi-Fi,
yeah,
right?
Correct.
And so the amount of traffic that might be being generated by LoRaWAN devices is surely, this is me talking from a position of ignorance, I don't know the answer, but surely it's relatively modest, even at higher data rates allowed with 2.4, than Wi-Fi devices are going to be generating. Is that right?
I think given the kind of applications we're talking about, it's erring towards a lower data rate type of application. You're not talking about, you're not going to be streaming video or anything, even audio is quite tricky at those kind of data rates. So really you're in an environment where you might want short bursts of uploading a bunch of data off a tag, for instance. Or you might want to update some firmware on your devices. That's a really key features, key functionality that 2.4 can provide. You're not actually going to want to flood the spectrum with your data.
Well, the firmware update one actually isn't one that I thought of, but it's clearly historically been one of the more challenging things associated
really,
with using
really
LoRaWAN, right?
Yeah.
And so you mentioned about you'll come to the end of this knowing what the killer application is. Is it firmware updates?
Well, that's one of them.
And if you can say no, well, that's fine.
So that's a killer feature, I would say. That's not, in my opinion, the killer app. And anyone who knows anything about convert technologies, it won't surprise you to know that I'm going to mention location. This is really our core development, our core IP. And one thing we haven't really mentioned yet is 2.4 gives you the ability to range or to measure the distance between two radio nodes. And this is achieved using a round-trip time of flight. So a packet effectively travels from one node to the other and back again, and we time the amount of time that it takes to transfer across that distance, and then we can evaluate that into an actual distance. And by using those distances, we can reference that into an actual location in space. And this has been a really big application point for us. It's generally more predictable and more repeatable than the sort of more traditional signal strength based mechanisms. It operates over a longer range, so you need less infrastructure. There are some advantages. I'm not saying it's the only way to do things, and in many cases it's not always the best way, but it does give you probably the best accuracy for the lowest infrastructure.
Dare I say that is also a feature rather than necessarily an application in its own right?
Okay, yeah.
But,
I think location is a killer app. I would say.
Yes.
That's my argument.
Deniss, can I come to you about the applications for 2.4 gigahertz? How do you see the applications for 2.4?
So we have a customer who wants to measure temperature, humidity, but with recent frequency. So let's say every 5 to 10 minutes.
Yep.
Which is not impossible with a sub-gig without violating the 1% duty cycle. Also, I want to show the device I have in my hands. So this is what Winke mentioned in the opening keynote. It has 2 bands, sub-gig and 2.4. The device cost is about $30 this price. So this is something that people don't need to choose between sub-gig and 2.4.
Yeah.
So in my opinion, these are not like competing technologies. They just each technology will be used in a certain use case.
So someone may want to use it with less frequency, and so they'd use the sub-gigahertz, or they might want to use it with more frequency, and so they'd flip it across to using the 2.4.
So in the use cases when you need a longer range, more battery life, then you will use the sub-gig. 2.4 if you want frequent updates, more bandwidth, maybe ranging features.
Yep.
So these are like complementary, yeah.
And in that multi-mode device type, is there a cost implication for it? I guess in terms of antennas, is it the same antenna or is it the same chipset?
The antenna doesn't cost much, but the chipset is just a single chip from the Semtech LR1120. So it's a multi-band chipset, so it doesn't add any cost to the device.
Okay, good stuff. Thomas, we've heard location, we've heard firmware updates, we've heard compliance. The duty cycle as a restriction. A couple of other things. Other things that you think are particularly relevant to 2.4 that make it a useful technology to use, maybe in comparison to sub-gigahertz?
So I agree actually with you that the location is one of the most important thing, but we don't see it, or I don't see it, that it's the localization with the round trip time, but more in the way of that we can use GPS tracker all over the world.
Yeah.
So a lot of use cases want to track international goods or even intercontinental goods. So for example, a cargo container on a ship. Until now, you cannot really track it with LoRaWAN because as soon as it changes the continent, you have no more reception. So a lot of customers ask, should I use different radio technology? And now with 2.4 gigahertz, we can tell them, no, we can do it with LoRaWAN, we can use 2.4 gigahertz. And as soon as the cargo container, for example, arrives at the port on a different continent or in a different country, it has connection, it doesn't have to change anything with the regional parameters or with the frequencies, but it just can continue sending. And we will know where our goods are all over the world. So,
for some of the people in the audience, or indeed who are watching the podcast version, some might not be aware about band fragmentation or lack of consistent frequencies at the sub-gigahertz band. So can you explain a little bit about that?
I mean, we're in Europe now. So in Europe, the 868 megahertz frequency band is used. That band is unfortunately not available or free all over the world. That's why, for example, in America or North America, they use the 915 megahertz frequency band. So if we took a tracker from here that is sending and receiving on the 868 megahertz band, move it to America, it would either be illegal to operate it there because of the law, or it wouldn't reach the gateway because the gateway would be listening on a different frequency. And this is a problem all over the world, so I'm not 100% sure how many regions we have. It's, I think, about 7, maybe.
Something like that, yeah. And some are using the same bands and some are using different bands, and so it's a bit of a patchwork.
So if you want to cover the whole world, it's getting really hard. But another point is, I mean, the frequency that we use is something, so I mean, it's nice that we have the same thing, but for hardware, I mean, it's much easier to produce one device that we can use all over the world. It's not even about the coverage that we can reach the gateway and communicate with the server or the cloud, but the customer only has to build one device that will work all over the world and will comply with the regulations in that country or in that continent.
Yeah, good stuff. That's the advantages. I want to think a little bit about the challenges. Deniss, if I can come to you first. Some of the challenges of deploying 2.4 gigahertz.
Well, of course,
if there are any.
Sure. The first challenge is the range.
The what, sorry? Range.
Right. The range, yeah, sure. Because 2.4 has lower penetration. So we test our device in the line of sight. We got 1.4 kilometer. No obstacle. So, as you know, the sub-gig LoRa can go like more than 10. The other challenge that
Sorry, did I hear that right? Sort of a 10 to 1 ratio
Yeah.
for when you have line of sight between the device and
well,
the
that
gateway.
maybe other suppliers can confirm, but another point is that 2.4 has a bit more power consumption. So the same device on 2.4 will consume a bit more energy per packet. Yeah, so it will, with a decent battery, you can still get like a good battery life.
Which may have implications depending on what application you're using it for. So, for instance, smart metering, completely not appropriate. Moving trackers, absolutely appropriate, because at some point it's likely to have something like line of sight to the gateway. Yeah. Thomas, any additional challenges you see with deploying in 2.4?
Yes, I mean, of course, the whole ecosystem is not that available already yet. I mean, if you look at booths or in the online shops or at the companies, I mean, most companies are providing their devices at US or European frequencies. So also gateways and devices, it's just not that many devices there yet. Our company tried to tackle that with our own LoRaWAN module that supports 2.4 gigahertz, which should accelerate the development of more and more end devices and sensors that support 2.4 gigahertz. So,
what have you heard from the gateway manufacturers? I'm interested in that. Have they got this on their? Will they say, "Oh, we have products in that space, it's fine," or are they building up a portfolio? What's the dynamics there?
They're here now. You can buy
We both have the
2.4 gateways.
2.4.
These guys are making them. So
we are producing them and supplying the world with 2.4 gigahertz gateways as modules and sensors.
Okay.
the only other, sorry to interrupt. The only other,
I don't think that was us. There was some other kind of noise interfering with people, but one of the joys of live recording.
just one more thing on the possible cons. 2.4 is a much busier spectrum.
Yes.
Everyone in this building has a device which is spewing out 2.4. So, you do need to be aware of interference. There are billions of 2.4 devices.
So more likely to have packet loss, more likely to therefore need to do repeat transmit. Okay, maybe it was you. And therefore that will have implications for battery power as well, right? I mean, you can just keep sending the messages forever and ever and ever until you get a response, but that's not great for battery.
Yeah, I mean, I don't want to give the impression that it's impossible to build systems at 2.4. That's definitely not the case. We are doing that successfully now. But you, for instance, you may not want to put a 2.4 sensor right next to a Wi-Fi router, for instance. That wouldn't be a good system design. To counter that, LoRaWAN is extremely good at noise rejection. It has one of the best noise floors I've ever come across in terms of really extracting signal from the smallest possible amount of signal available.
Okay.
They're doing their best to counter that. They really are.
Okay, that's interesting. Okay. So we've talked. It mostly seems to be a tracker's use case. Is that right, or are there other use cases that you're seeing which are more which are seeing some wide adoption in? Because we've talked. Okay, when we've said pros and cons and some of the great benefits, we haven't really necessarily talked about which verticals, which use cases specifically, other than generically trackers. So are there some verticals and use cases that are likely to be opened up as a result of 2.4 being available?
Yeah, shall I go quickly?
Sure.
So I think I'm going to answer that by saying trackers is a major part, mainly because that's a big part of our business. But it sort of opens up new possibilities, right? So probably many of you guys in the audience are interested in producing sensor data. You're using LoRaWAN to return sensor data. Now, if you can attach that sensor to something that moves, and you can attach a location to that sensor data, the value of that data goes up exponentially. Now you know that the temperature in this point was so much, and this part of the building was a different temperature. That could be really valuable. So that's really interesting. But also with more bandwidth, you can start to look at more sophisticated sensors. You can look at really, spectral profiles for vibration, do really, really complex stuff for shock and vibration in particular we're looking at for one of our customers. And these may not be something you want to return all the time, because that would kill your battery, as Deniss pointed out. But for something that maybe when you hit a threshold, you want to really see exactly what happens in that shock, and you really want to analyze that profile, that in itself can be a really, really useful application.
Yeah. Okay, other applications, Thomas, Deniss?
I mean, I think, so the biggest disadvantage of LoRaWAN 2.4 gigahertz is the range, or that's what I think. So to really make a good use of 2.4 gigahertz, you need to kind of confine the area where you want to send and receive stuff. So either you do it by adding certain gateways at certain points in the world where you know if the sensor is connecting there, the device is there, or you have to really use like a limited area. For example, maybe a company or a factory that has like a big yard with machines or machines running that you need continuous updates or almost continuous updates. That would be a great example. I mean, I'm from Switzerland, so there we have sub-gigahertz LoRaWAN coverage in the whole country, or 99% of it.
That's another topic I wanted to get onto.
And we will probably never reach that with 2.4 gigahertz, because with that range, that would be too many gateways. I mean, we would like to sell that many gateways, but I'm not sure if someone is going to pay it. So, yeah, I think we need to really confine the space where the sensors are. It might also be like something, a hospital or a big yard in a company, stuff like that, where you need really a lot of updates with a high frequency, but the long range is not that needed. So.
But also the in-building propagation characteristics aren't as good as they are at lower frequencies, so this is a bit challenging. Yeah,
so a big yard, open yard with machines or cars or vans is probably one of the ideal applications for that.
Yeah. Deniss, any other use cases, applications, verticals that you see as being particularly interested in this space?
There are not so many. I hope to have more after we release the device. Have more customers. And, talking about the challenges, I also see one of the challenges that the gateway design that we are using now, it supports only 4 channels, so it can distinct between 4 different spreading factors. So it's not the same as sub-gig. So maybe improving the gateway design also would help to increase the capacity.
Good stuff. Okay. You mentioned about Swisscom. You mentioned about Swisscom running public LoRaWAN networks.
Yes.
There's not any intention of anyone to run a 2.4 gigahertz public LoRaWAN network, right?
Not that I know of.
I'm also not aware. I just thought I'd ask the question, right?
No,
that's what we're here to do, ask questions. We're not aware. Okay, in the couple of seconds we've got left, thoughts on where you see 2.4 gigahertz going in future? If I can start with you, Dave.
Yeah, real quick, we're very short time. I think, you know about the killer app? I think combining 2.4 with sub-gig is an absolutely huge area. Don't think of it as something either or, think of it as both.
Excellent. Thomas?
That's exactly my thought. Not one will replace the other, but they will exist in coexistence. And I think that's good. Both have advantages and disadvantages. And if you can consult the customer and lead him to the right decision for his devices, I think both will be a big part of LoRaWAN in the future.
Excellent. And Deniss?
Well, I wish that 2.4 becomes the LoRaWAN Alliance standard.
Okay.
This is what we are waiting for.
Excellent. Okay, good stuff. Gentlemen, thank you. And thank you all for
everyone
joining us.